Hi, my name is Fredrik Rutz, and welcome to EdTech Malmö. This is the third installation of this meeting, the user group. Today we're going to talk about AI, cognition, and how to promote learning with Magnus Johnsson here, who is a senior associate professor at Malmö University in AI and cognition. Thank you for being here.
Thank you, Fredrik. Okay. A little bit. I will start with a little bit more introduction about myself first. But I also want to start by saying that I want to have a discussion also. So please don't be shy. So I will start present. I have made slides so it can last all the time. But I would prefer if we go into a discussion, a little bit in brainstorming mode or something like that. So there are no stupid questions, there are no stupid comments, and so on. So please do that. Yes, I have a background in cognitive science from the beginning. So I'm actually cognitive science researcher, or I have been between artificial intelligence and cognitive science. So I want to have a kind of slant of cognitive science here as well. I also want to present another person here in the audience, namely Deepak Surya. He's my collaborator. So I want to present him because he's sort of involved in what we now are doing. I have a background in artificial intelligence and cognitive science, as I said, but when it comes to artificial intelligence and applying it for learning, I'm not that experienced. We have started a new research track, and that's also why I want kind of brainstorming session here. And there are other people doing this, but we want to also add, cognitive science slant, because you can create artificial intelligence that promotes learning, but you can do it in various ways. And to make it even better, it is important to take into account the nature of human cognition and the nature of humans. So back to Deepak here. He's also a senior lecturer at Malmö University. And I also have to say he's a winner of Venture Cup, so he's a kind of entrepreneurial guy as well. And I hope that he will help me get the discussions going if the others of you are too shy, but please don't. Okay, so let's start then, so that everyone knows what artificial intelligence is, because now I don't know about your background. I guess that we have various kinds of people here. So let's start with that. Artificial intelligence, well, what is that? Well, it is a kind of effort to create technology that can do what normally takes intelligence when humans do it, so to say. And then we can get back to what is intelligence. So it quickly starts to become rather messy, and I just want to point out that it's not very easy to put up the constraints or borders here. But that is a good working definition, at least. What normally takes intelligence for humans to solve. Example of such software that can do that is, for example, a very classical example is a chess playing program, as you probably all are familiar with. That's very classical. In the beginning, it was used to as a kind of benchmark to show that if you can create a program that can play chess in a good way, then it must be very intelligent, right? It turned out that those kinds of problems was not the hardest one to do. It's much harder to do many things that an infant can already do. And other examples is, for example, AI used for diagnosing things like medical conditions or what's wrong with your car when it doesn't start. When we go into what's called expert systems. And then we also have a subfield in AI which is called machine learning. And I will get back to that, but on the right side of a slide here you can see I talk about biologically inspired AI, and some of the machine learning comes from that part by inspiration from biology, like neural networks. You can already hear it on the name. Genetic algorithms, which tries to mimic evolution to find solutions. You have reinforcement learning. It is a way of mimicking operant conditioning, and so on and so forth. And then you have you can also talk about narrow AI or domain-specific AI. That is what we are very often talking about. Like, for example, chess-playing program can play chess but nothing else. But you can also see it as a kind of continuum. So I'm just saying this because so that we know what we are talking about here. And at one end you have like chess-playing program, for example, a neural network that can do very narrow things. Maybe it can categorize a particular kind of data. A little bit further to the right there you have more complicated systems like an autonomous car. And when you go further to the right, potentially you reach a kind of human level general artificial intelligence. We are not there, but people are researching that. Among them, I am one of them actually. But if you could also imagine that could go beyond that and create superhuman artificial general intelligence. But that's the question if we can do. There is a question if we can do it, and there is a question if we want to do it. So one part of AI is then machine learning. And what is that exactly? Well, you can see it like it's computer programs that improves through experience and learn how to respond to input, rather than you hard code it. You know, usually you write a program to carry out the task, but if you can instead create a program that learns to do the task based on the data it gets. And that data can be various things. It can be it could be from an artificial perceptual system, like a camera and a system that takes care of processing that input and so on, or an artificial hearing system, or it could be just that it processes kind of already pre-processed data of any kind. So that is computer programs that learns. That is what we can say from a more general and abstract perspective. One part of it then, as an example, we have neural networks. These are, that is a class of algorithms that they are not mimicking necessarily natural neural networks. They are rather inspired by them. They could mimic them, but there are also algorithms that are only taking inspiration for it. And what's common for them is that they have processing units, which corresponds to neurons. They have connections that you modify, which corresponds to synapses in the brain. You have activation functions, which corresponds to action potentials in the brain. And you can have various kinds of architectures of these. And these can solve problems. They are learning by modifying parameters, which correspond to synapses in the brain. And basically, you can see it as parameterized functions that learn based on the data you feed them. They learn a function that relates the input data to or I'm simplifying now, but it relates input data to wanted output, so to say. Or that's one class of neural network, at least. And then you have various kinds of tricks to get the parameters but do this in a good way, so that it generalizes to unseen input and so on. And a particular kind of AI is recommender systems. And you all encounter them every now and then, I can say. Recommender systems, they predict the preferences of the user. For example, you have recommender systems that generate suggestions for you, what kind of music you want to listen to, based on, for example, what music the history of what music you used to listen to, and also by looking into profiles of people that are similar to you, according to some kind of similarity measure. Other examples is, you have online dating, for example, trying to match the profiles of various kinds of people to help out with that. It can be applied to finding collaborators, for example, experts, and why not financial services? It can, for example, recommend a user to particular kinds of financial services, or from the other side's view, maybe it could recommend the lender to not lend out money to some particular customer, for example. You can say that it's hard to explain in detail things here, but you can see it like you use item descriptions and profiles of users and their preferences, and relate that to how various users are similar to each other and so on. You have various kinds of filtering mechanisms depending on what kind of recommender system it is. And recommender systems are, in a sense, particular important here with respect to what I will go into later during the presentation here. I said also that I was a cognitive scientist. And so, what on earth is cognitive science? Well, cognitive science is, it's cross-disciplinary research of cognition. So, what is cognition? You can explore that from various kinds of starting points. You can have a philosophical starting point. You can study it from a neuroscientific point of view, a psychological point of view. From computer science point of view, because artificial intelligence, when you go into artificial cognition, so that doesn't only have to be natural cognition, it could also be artificial cognition, and so on and so forth. So now about artificial intelligence in education then. There are many already existing applications, and there are many possible applications. I will mix this a little bit, and it will not be exhaustive in any way. I will just bring up some examples of possible applications, possible and existing applications. One is that you could use artificial intelligence in games, where you use the games to learn or to teach. And actually, one could say that this is nothing new, that you use games to learn. For example, what you can see here on the slide, you have chess, for example. Well, you can see that as a game where you learn strategic thinking in a very abstract way if you as long as you have the right kind of perspective on it, right? You can learn a lot about that. You can also play chess and become a good chess player without learning these lessons, I would say. So it's also a matter of the perspective on how you use it. You could use Rurik's cube to perhaps improve your spatial thinking. And there are also many approaches where people try to create like video games and so on, where you can also at the same time learn something useful. It's a very, very good idea. Why is it a good idea? Well, because you catch the attention and motivation of the students, even more so if it's children. So if you can play a video game and at the same time learn to multiply, for example. You have to multiply because you have to pass through certain gates, for example, and you have to, or other tasks, so it can create a motivation there. But that's one way to do that. Then I will also bring up something which is somewhat related. It's about systems that aid people with special needs. And then you might think that, okay, now it gets a little bit sidetracked here. But it depends, because you have people with special needs, and in a way we all have special needs. We are all unique, you know. So maybe we have some weaknesses, or maybe we shouldn't say that it's weaknesses either, because it could also be seen like some there are communication problems between people. So for example, it might be how if you, for example, are autistic, you might have problems by interpreting emotions and body language. So maybe you could improve that situation for such people by using technology and AI. And how on earth could that be done? Well, for example, you can have automatized body language recognition, and then you could put labels so that they can interpret it in a more intellectual way, you see, which I perhaps are very good at. So, and emotions, for example, you have a particular there are a bunch of universal expressions that exist everywhere, in every country, every culture, and so on. There are universal expressions for various kinds of emotions, such as anger, fear, and so on and so forth. But some people have problems of recognizing them. So how could you teach them, or either help them or teach them to do that? Well, if you can create a system that can automatically recognize these things, and you can, at least potentially, by using machine learning and neural networks and such things. You can teach these neural networks to categorize various kinds of expressions, for example, facial expressions. And then you could put a label on them for those that actually have problems of interpreting that. Okay, this is how anger looks, or this is how fear looks, or whatever. And also, potentially, if more complicated, body language, for example. You could also automatic body language detection. For example, I have worked with action recognition, or you could say gesture recognition, where built system that can automatically detect some gestures using a camera. But if you go a little bit further there, okay, maybe it can give an interpretation to what the body language means, and put a label on it. And then you could also use other technologies. It's hard to sort of isolate also. We are talking about AI for learning, but it's hard to isolate technology, because it all goes into each other. So AI with augmented reality, for example, is a good idea here, I would say. You have a AI in the form of systems that can recognize certain things like body language, emotions, for example. Just as example, the sky is the limit, in principle. When it might sometimes be hard to do it in reality, that's granted. But then, okay, if you have that system, then you can use augmented reality. You superimpose, for example, by using certain kinds of head-mounted displays. You superimpose, or glasses, or whatever. Or even on the screen. You superimpose, for example, the labels, as I said. Or what does that? What does it mean, actually? That's an example. Another example is that also already exists, but systems can be more or less sophisticated. So, for learning language, as an example, you can train pronunciation. You can have systems that helps you with that. That gives you feedback on your, what should I say, sound image, the image of a sound, of a particular pattern of frequencies and so on. Does this sound right? No, it doesn't sound right. And how is it wrong? How should I do instead, right? So that I can train without a teacher my ability to pronounce things in the right way. That is particularly important for people that learn a language after puberty, because then our ability to pronounce it correctly declines. We can still learn a language perfectly, but it's very often very hard to learn it without an accent. So that's one example. Another example, an idea, I touched it before, is learning, for example, to perform physical movements, dancing, for example. Potentially, how on earth is that going to happen? Well, I told you before that I have been into building gesture recognition systems together with former PhD students that I have supervised. And that works fine. So potentially you could develop that further so that you also, the system does not only recognize the movement, for example in a dance, but it can also suggest improvements to move it towards some kind of ideal movement, perhaps for that particular body or whatever, and other parameters, and give kind of feedback, automatic feedback. Okay, do change your move in this or that way, for example. So that's one thing. This is something that I will not talk very much about it because we should focus on how can we use it for learning, not for scoring. Fredrik pointed that out to me, but I will mention it anyway. So it can be used for you can use AI for automatic scoring, and why it's good for learning. No, it's not good for learning, but it's good for teaching, or to save the time of teachers, so that it can be used more constructively. For example, to coach the students rather than sitting with a huge bunch of essays that you have to grade manually. And it's not, again, like the scale I gave you before, from narrow AI to, or domain-specific AI to general AI. It's not either or, it's a continuum, you know. You can have, maybe it can scaffolding it or help you, support you, rather than doing it. It's not either or. Here's one thing also, I will just shortly touch it because I have some problems with it, rather than I think that is good. It's particular, I read a paper from China. They think this is a good idea. And maybe it is, if used in the right way. You can monitor the classroom to see how is the attention of individual students, of paying attention, of aware or so on. But I would also put up a warning for this. It is not. I don't like this really, because it can lead to kind of panopticon, and now I don't remember word by word, but they cited in one paper, a student was said from China, but they have started to use this, and he or she said that it felt like they didn't dare to relax, and it was like they had a sense of being watched all the time. So it's like a panopticon, which is, as you might know, a kind of prison where you have a watchtower in the middle, and they can see everything, but you cannot see them really, all they are doing. So that's not something I will develop further, at least. Now this is not AI, but just to give, it's related anyway. Time is going, so but when you use AI, then often it can be good to also have good presentations of what in these kinds of settings, what the AI is coming up with, so to say. So one example is that now you have a model of a human here, but let's say you had, let's say you should have a system that sort of recognized various parts in various individuals, because we are all we don't look exactly similar inside. In reality, it's what we see in images and so on is kind of a prototype presentation or visualization. But if you have a system that can recognize things, then you can superimpose it with augmented reality. It's just to point out that it's a good way to also present what AI comes up with. And you could put in a little bit more AI, for example. It could figure out how a house would look by you just looking at a drawing, so to say, or a sketch. And yes, this is just another example of augmented reality. If you point at various things, maybe you can get explanations, more or less detailed, what is everything. And when I talk about augmented reality, we could go into something related, that is virtual reality, which is also obviously a good tool when it comes to learning. For example, you can create a virtual world that these people see, which also use AI for, of course, where you do various kinds of tasks. It could be everything from learning to, potential at least, learning to do surgery, for example. Have a lot of possibilities. I know that there are at least research dealing with that, because then you can train a lot without actually having to cut real people or animals and so on. And there also, of course, augmented reality comes in. You can superimpose on, for example, a kind of a model or doll. You can superimpose what happens when you cut it and so on. Yeah. Yeah, of course.
Yes. I'd just like to go back a bit to the scoring part that you said that you didn't want me to talk about. I think scoring is extremely useful, and I think the scoring, the feedback on the scoring, the feedback on the scoring is extremely useful as a way to teach stuff.
Yeah.
Can you say something about the state of the art of helping essays, qualitative hand-ins, and how I can provide feedback in, let's say, I'm going to teach Swedish, and that the system can help me correct grammar in a way that the student can actually learn something, not like just a slap of the hand like Microsoft does, basically.
The state of the art, and I have a trouble of actually, I don't dare to really do that, but I know that it exists systems that can help you doing this, but I cannot say to what extent they're doing. And I think it's very dependent, domain dependent, and so on, also, and what you can do. The grammar is one thing. Potentially, it should also be possible to point out something about the content, like a kind of semantic understanding at some level within a particular domain or something, but I can't say what the exact state of the art there, I'm afraid. Anyone who is aware of that here? Deepak, for example.
Yeah, thanks a lot. Like, I don't know exactly like if there are specific systems, but you sort of like talked about the semantic aspect. I think what we need to look into is like beyond just like, you know, simple grammatical stuff to actually understand like the meaning of like the sentences that are there. And then to sort of like in this context to provide like a kind of like a summary for like the teacher to be able to sort of have a discussion with the students and to be able to yeah, more or less like teach the student instead of like being like in a situation to actually go through the entire essay. So I'm not like aware of the latest one, but I think like the semantic way is the way to go, I guess.
Thank you very much. I will move on, okay? But please interrupt me if you want to ask questions or have comments. So we're here. I will speed up a little bit so we can have a discussion at the end. 5 minutes more and then I will shut up. Yeah, simulations is another thing, of course. Also you can create various kinds which could also involve AI. For example, here is maybe what you first think about when I say simulation, a flight simulator or something like that. Yes, that's one way to look at it. But you could also imagine simulations of let's say chemical experiments where you don't actually have to blend the chemicals and so on and have dangerous reactions and so on. Rather, you could simulate it and what would happen will happen within the simulations. So that's one, I think, very interesting possible application. And there are, again, although I don't want dare to say exactly what the state of the art is there, but I know that there exist some systems in that direction also. Although I cannot say exactly the state of the art. Adaptive learning systems. That's I don't know if we should skip that and move on actually, because time is going, because I want to have a discussion on the end. So if I have time, I will go back to it. I will just want to mention something about cognitive science and stress some points here also before we have a discussion also, and then I will tell you about a particular platform that we are trying to develop. Cognitive science here is it's important for, because we know we all have to relate it to how humans actually work and the properties of humans and in particular cognition when we try to build or apply AI for learning and for teaching. So one thing that is also something, if you're aware of user experiences or what is called user interface design and so on, you use certain principles nowadays to make them useful, and so you use cognitive design principles that takes into account. I will not go into exactly what it's because we don't have time, but you use certain principles for how to design things so that it's easy to understand how to use something, how to use the user interface. But this should be in analogy with that. That should also be applied here. That is one of my take-home points here. We should use these principles. And another think it's also something, maybe someone of you have heard about the universal design. It's something that I really like, actually, and I want to push for having that included when we design systems that employ AI for learning and teaching. And universal design, it's a principle that we always should have in mind when we design something. It doesn't matter if we design a stair, or if we design a user interface, or given that you have time enough for it, because it's easier said than done, of course, but it's an ideal. But also when, for example, if you're a teacher, when you design a lecture, an ideal there when using universal design could be to, can you design it in a way so that you speak to all kinds of cognitive styles at the same time? It's really hard, but you get the point. One easy example is you can communicate with pictures, you can communicate with text, you can say things, and so on and so forth, and gestures and so on. You can, I'm talking about an ideal when it comes to teaching, but we should have that also included when we use AI for learning and for teaching. We should not forget that, because I think it's very easy that if one has a very narrow-minded view on this, we will end up in something similar to when we have, some decades ago when the user interfaces to everything was beyond belief in how bad they could be sometimes. And not intentionally, just because it was people that didn't understand these things that designed them. They were experts in other and brilliant in other things, but they didn't understand even basic needs of humans for understanding something. For example, I remember in the 80s, I had to read the manual for the video recorder every time, no, because it didn't stick, So when you should do it again, you had to read the manual again. So it's not that way nowadays. And that brings me into also another concept which is called affordance. What's affordance? Well, and I also want to bring in that so it's a little bit hard to communicate it, but in affordance, usually when you talk about that is things should be designed in a way so that they invite the right behavior, right? And that could be everything from designing a door. It should invite you to push when you should push, and invite you to pull when you should pull. It could also be more nasty areas. You should design the environment in a city so that, for example, it doesn't invite crime, for example, I would say. People should not be criminal, I'm not saying that, but you could design things so that you decreases the likelihood that it happens, for example. For example, if you design something in glass, where you wait for a bus, for example, the shelter, it almost invites certain kinds of people to smash it. If you design it otherwise, it may not. For example, only if you have a blank surface, it invites something to scribble on it. If you put some pattern on it, the likelihood goes down a lot. But what I mean is that we should have these principles here also in a kind of an analogical way. So in these kinds of systems where you use AI for learning as well. And I just have to remember the KISS principle, keep it simple, stupid. But that is something or it's an acronym for that. It means that also I want to point out something for those that are interested in going into building or using, either creating or employing AI systems for learning. What I'm after here is that don't use something that is not improving the situation. If you can do it easier without AI, don't use AI for that task. Only use it where it adds some value. And then we can apply AI where it is really contributing something. That's what I mean. I think I will skip that. I also want to actually to add some of my own perspective. I've been a teacher for a long time also. But one thing I can point out here is, or a second point here, something that I as a teacher have really learned is that something that's important for students is self-confidence and self-esteem. If you can get that right, learning becomes easier. So the teacher's role is, to a large extent, in my view, to cultivate the self-esteem and in particular, don't break it down for the student when you have sort of put up a huge obstacle for learning anything. And why am I mentioning that here in this context? Well, because that is something we also should have in mind when we design artificial systems. They should try to mimic that. Can we provide feedback that you know, make the self-esteem blossom for the student rather than trample them down. That's my point. Now, I have to mention this also. So we can have a discussion when we are eating pizza also, maybe. I just shortly want to tell you about a system that we are working on. Deepak and I, and there have been students involved, and we have discussed for a long time how to try to come up with a platform that fills the gap between academic education and the needs in the industry. We sense a gap there. And what we are after is, what we are trying to do, and which is related to what I'm talking about here, is creating a learning platform that help job-seeking students gain experiential learning through industry projects and internships and active engagement with small and medium-sized enterprises. And why is that interesting? Well, because the idea is to creating such a platform using AI and recommender systems that guides them without them even actually noticing it, perhaps sometime in some respect, so that they gravitate towards projects that are useful for them and suitable. And the other stakeholders, for example, the industry, the employers, they can test the students, the student get experience, and even if it doesn't lead to employment, the student has gained experience, learns things. The employer might have got some tasks done with by someone that they still didn't want to employ, and everyone should be happy, and the society also should be happy. All stakeholders. It's an idea to create a kind of win-win situation for all stakeholders, so that there are never any losers, only winners to various extents. And which I said here, no matter what the outcome, so to say. So it's not that you have wasted your time. And we want to use AI for that, and especially when kind of recommender systems to do that, and other kinds of sophisticated stuff that more sophisticated stuff that I cannot go into here now. And so that they also get a better self-understanding. The idea is that the students should sort of follow a track so that in the end they land in a job that they will get, and it is actually the right position for them, and it's the right position for the employer. I mean, it's to do this fully might be hard, but we try to approach it gradually. And with that, I will just say that I'm done there and I've used all the time for talking. So, but can we have a few minutes discussion and then continue the discussions when we eat pizza, Fredrik? So, also one thing, if anyone is interested in this that I talked about now at the end about this platform, if it sounds interesting, you want to know more, come and talk to me or talk to Deepak, because we are going to develop that. And we follow two tracks. One is kind of entrepreneurial track, and another is an academic, which we have just started. So we are trying to, we are going to do research to build on this, so to say. And it could be good with collaboration partners. Everything from teachers to entrepreneurs and to developers, everything. Everyone is welcome to discuss this with us. You can also find contact information to me if you want to talk with me later by following the link here to my website. It's also written on the announcement page, I think. And there you can find email address and so on. Yeah, should we have a short discussion and then have pizza and continue discussion? But is there anyone that spontaneously want to comment, ask something, or so? And again, please don't be shy. This should be a brainstorming session.
It's not a question, Mike. It's just a thought about. I'm a high school teacher.
Yeah.
And I'm thinking from a school perspective that the easy way to incorporate AI would be, as a teacher, would be on the administrative functions, on all the paperwork.
Yeah.
What do you say about that? I mean, I think that's sort of the.
Yeah.
I would say that's the place to start if I'm thinking from my school perspective.
Yeah.
That's what I want them to use the technology for.
Yeah. You're totally right, and I think it is there. It has started by trying to automatize various kinds of administrative tasks and so on. Because then you release time for the teachers and for the administrative staff as well, of course, so that they can. So you're right. That is a matter of automatizing things, and that is also brought up in the literature about using AI in education. But I left it out a little bit because I wanted to focus on other things. But you're totally right, and that is important too, of course, absolutely.
But is there examples? Is there good examples? The thing we talked about, the semantic part here. Do you know any good example that have had a good success there? To teaching and things like that.
Like scoring papers, as we talked about. You mean?
Yeah, or using AI. To teach, to learn, really.
Yeah, to learn. One example is, for example, learning how to pronounce words. There are such systems existing, for example. And there are games, educational games, for example, with some degree of success, depending on who who you ask, I would say. So, yeah, that's two examples. Do you have some examples to bring up there, Deepak?
I just don't know like in which university, but it was in a university in the States where like students would actually like do their assignment work, and then like they just submit it, and of course like they are graded by the teachers, but one of the teacher was actually an AI system, so it was not actually a real teacher or a teaching assistant in some sense. And then like and say it was not for like the entire class, so some students were like submitting their work to this kind of AI teaching assistant that's there, and they actually got like a very good feedback and stuff. In fact, like they actually got like instant feedback and stuff, and they were pretty happy until the last day when the teacher actually revealed that like of all the teaching assistants that we have like one which is just an AI, you know. So I think like there are progress, I guess, but the semantic part is also pretty hard to work with, and it depends a lot on the context and stuff. So if we have like a more closed world, maybe it's a bit more easier. The more open kind of intelligence we want, it's ongoing research, I would say. So, thank you.
Okay, I will do it fast. So like two reflections while you talk. So one is, as society, somehow our loss of focus. Let's say that technology is developed, social networks have developed technology that compete for our attention. Technology make us buy more, being more connected with social networks, but somehow even after one pandemic that we have been using all these for 2 years, we haven't developed a lot of technology that help us to how our childs or learners could connect better with these tools. And a bit linked to that also, the sense of awareness and responsibility from the ethical point of view as developers.
Yeah.
So we are in a environment where we produce a lot of technology, a lot of software, a lot of AI. So to what extent we as consumers are aware and developers are aware that what our kids watch in YouTube, there is also an AI that is recommended what to watch next, and it's probably not to follow more education, but to give their attention. So, yeah, things that we have to reflect as well.
Yeah, I think it's a very good point, if I may comment on your comment. And that is kind of related to various things here. But one reflection is that it depends on, the problem here is that it's very important that we decide what we are going to optimize for. And it's a pity that in this sense that they optimize recommender systems and the design of games and so on, not always because it's beneficial. It consumes the user sometimes to an almost pathological extent without giving anything useful back. I'm thinking about certain kinds of games, for example, where you can consume all the efforts and all cognition and so on, and you don't get very much learning, for example. So there is a challenge then with these educational games. That should be kind of some remedy of that, maybe. But it's a very hard problem, as you say, and probably it has to be addressed by what you're indicating yourself, by every one of us being aware, and also adding kind of ethical perspective to everything we are doing, and not only exploit it if we can exploit it just because we can. And we also have to be aware what happens to the users of a product, for example. What happens with the children's education if we are consumed by certain kinds of games or social networks to an extent that there is no room for education anymore. So you're perfectly right.
Okay, let's go discuss informally more with pizza and beers for those who want, or other drinks for those who want that. Thank you very much, Magnus.
Thank you.